Cool. So, hello, I'm Matt. I go over by Brimstone in online channels. There's my Twitter, and I'm trying out this new thing called Mastodon, which is pretty cool. It's like Twitter, but not Twitter, so you can follow me there too. These slides are also on my website, which is the last link. So if you want to just follow along with the slides, some of them are a little dense, so you can take them with you for later. I presented at Freaknik a couple of times now. I've been going here for like 10 plus years or so. Loads of fun, nice little conference. Glad everyone can make it. Tell your friends. This is the text that's on the website. I noticed that it wasn't in the program, so I'll pause for a second here so you guys get a chance to read it. But this basically describes what Make is. Most of this is stolen from the Wikipedia page. So if you want a bigger definition, you can go read it on there as well. But the big takeaway that I want to talk about specifically is that Make can be used for some files, must be updated automatically whenever others change. This is basically what Make does. This is a tool used primarily in building software. It can be used more generally to automate software or automate different actions involved with either building software or doing other things. This isn't an automation tool like Home Assistant was that we talked about earlier. This is more of an automation tool when you have like software packages, or if you want to compile a program, or if you want to do some sort of like deployment of a program or a process, just to rein it in. Like this is more specifically around like server automation type things. It was created written in 1976 by this guy named Stuart Feldman. Also the author of the first Fortran compiler, which I thought was kind of cool. He's part of the original Unix group over at Bell Labs. So it's been around for a little while. Basically, one of his friends spent a lot of time trying to write a program, and he wasn't compiling all of the different parts. And this guy says, "Oh man, we could make the computer do that, and like automate that, and just detect when the programs change." So there's more information on his Wikipedia page. Those are just the interesting highlights. So it was included in early versions of Unix, which led to it being very widespread. It's configured via Makefiles, which just these little plain text files. There's nothing magic about the files. They're not like an encoded binary blob or anything. You can just open them with a text editor, change what the rules are, what the rules do, what the rules depend on. It's basically shell scripting, like we were talking about earlier. It's just a set of different commands and things that you can say that when this file changes, I need you to go run these things, and that'll produce the artifact that we described earlier. So how Make works, there's two different interfaces to it. There's the Makefiles that are just tangible files on disk that you can edit with a text editor. There's also the Make command, and that's what reads these Makefiles and then does the actions described in the Makefiles. The general model is that it looks at the modification times of the different dependencies, and if something is newer than that artifact that you want to produce, it then runs the commands needed to produce that artifact. It doesn't run through all of the commands in your Makefile unless it needs to. So it's a little bit optimized in that. This can be described as building a dependency graph. It builds a graph of the dependencies, only rebuilds what it needs to and is changed. How that looks visually, because I'm more visual, is that if you have a hello.c file and a hello.h file, and one of them changes, both of them are needed in order to produce this hello binary. So if either of them changes, it reproduces it. There's a couple of popular derivatives. There's GNU Make, which is what I'll primarily be focusing on today. And then there's BSD Make, which is also pretty popular, or PMake, popular in the BSD community. You'll see that in the FreeBSD operating system and its build system and how it installs packages and things. There's a ton more on the Wikipedia page for Make, so there's a link there in the notes.
So what's bmake?
I have no idea what bmake is.
Yeah.
I mean, it sounds like another derivative of some sort that somebody wanted for some reason or another. There's a native build of GNU Make for Windows that works okay from what I hear. I'm not a huge Windows guy though. Some coworker was talking about it, and he said that GMake also works well under the Windows subsystem for Linux, or the WSL thing that they added now. You can just install Make there, and it works fine. Everything's good there. The manual is online for this as part of the GNU project, and is super thorough. This has all the neat, like, different bits and bops that you would need to know about Make. It's like your one-stop shop. Is this? Oh, I've got everything out of sync now. You can see, hopefully, from there that there's a couple of different versions. Like, you can download just a PDF file and read it offline if you wanted to. And then there's the HTML file that's entirely in one web page. There's another version where it's just broken out per the different bits. This is the resource that I go to and use when I'm looking up, well, what's the rule or what's the variable that lets me do that thing, or what's a list of functions that I have available. This is where I go. And I'm afraid I've gotten everything out of sync now. It's soothing, just focus on the talk and not when stuff is acting weird. All right. Makefiles, they're conventionally named just capital M Make. They could also, like a lowercase m Make will also work, but convention is to make that an uppercase, which is a little weird in the Unix world already. There's a couple other names you can read in the manual that'll also work if you just absolutely don't want to use that file name. They're plain text. They don't have to be executable either. You don't have to mark them with an executable bit. They're just literally a text file. They don't need the shebang line at the top, that like pound bang type thing. You could do that. There's apparently some other like weird tricks that you can do, but no, like, we'll skip that. You don't need that. You can just start writing your rules that you want. They are white space significant though, and this is where I'm really conflicted because I love Make, but I hate the white space significant files. You have to have a single tab inside each of your commands. I'll touch on that a couple more times, so don't worry. And they're declarative. So you basically say, like, in order to get to this file, this compiled program, I need these dependencies, and here's the commands to run them. It's not specifically a top-down type thing where you say that it's this file, or you run this and run that, etc. You say, no, for this file, I need these things, go run that. So that way, it plays into that graph and it builds what it needs to. The basic syntax for a Makefile is you've got a variable equals value at the top. You then have some sort of new line break. You do all your variables on the top, and then you do all the different targets that you have. The targets then are comprised of components, separated by a colon on there. And then each of the commands in order to generate that target is indented with a single tab character. So that's it. There's no like 2 tabs, there's no spaces. We see where Make stands on that war. Variables first, then targets. Yep, single tab. Can't use spaces. So a basic example of a Makefile is literally just these 2 lines. You can say, hello is generated with hello.c, that's source code program. Does everyone understand the whole like .c files and then the .h files are just headers that have definitions about the functions that are described in the C file? If not, it's just, you need both of those to do the compilation. So like this is a super simple example that isn't complete. It doesn't say that you need that hello.h header file. You could add it in there though. Simple, easy. And then the terminal, just an example. When you run make, it compiles that single target that we have and generates that hello binary that just hangs out in the directory. Does everyone understand the GCC syntax too? I just want to touch on and say that the -o, the word after -o means that's the output file that we want to make. It's got the same name as the target line at the top there onto the left of the colon. This hello here lines up with that hello there, saying that in order to get to that binary, we need to use that file, which is this file here. It's the same reference things. You can, I'll show like a variable example later, and you can make that a little bit cleaner. And then everything else is the source files. Any questions about Makefiles or Make right now? Gives me a chance to get a drink too. So some conventions. We'll talk about that all the variables are at the top. The first target is usually just one named all. The default target when you just type make is to run the first target, or unless you've overridden it with the default goal variable. So people usually just say all is to do this, that, and the other. There's other targets called like build, which may also build things. Sometimes people will just say all : build, and all is the build target. There's an install target typically on things, which actually installs the program. There's a clean target, usually that undoes everything that all did, so whatever like compiling stuff that it needs to do. And then there's a dist clean target typically that then makes that directory like it was a fresh checkout or a fresh uncompressed from the tarball or something. So if there's any like configuration step or something that you needed to do, then dist clean usually reverts that as well, where clean doesn't usually. But so an advanced example, and there's a lot going on here. So reading through this real quick, there's an include line that goes and includes out another Makefile. So if you had multiple projects and you wanted to share like some common build steps between them, you could go stick those in a different file and have all of them include that, so you only have to change it in one spot. Includes are pretty cool. Then this defines a couple of different variables, defines like which compiler we want to use, stores that in a variable called cflags, which down here is where we actually called cc, and down here is where we would then actually call the cc. This is for if for some reason you have a different C compiler that you want to use. There's a couple of them out there, I hear. Compiler flags, another one, just common variable for compiling C programs. You can then say, you can define a variable that says, like, here's all of the dependencies needed in order to achieve most of my targets here. Then there's some interim files that I want to make along the way. And when I'm done, I want to store all this in a file called hello.make. That's my end goal here, is to create a hello make binary. And then there's a spot where to store it. There's a couple of different, let's see if this, there's a couple of different assignment things you may notice up there. There's a : which basically is just a direct assignment wants this works how you would think normal assignment works to a variable. There's a ? equals assignment, which basically says if you have an environment variable by the same name, then use that instead of what's specified in the file. This makes it super easy for people to override the C compiler or the name of the binary or something in our example here. So if I set the environment variable binary equals mat instead and then typed make, it would make me a mat binary that's exactly the same as the hello binary, or the hello make binary. If you use a single equal sign though, this one's a little weird gotcha in that it's like a recursive type assignment where if any of the variables involved in assigning to that variable change, it'll then figure out what that variable needs to be and update it and everything. Basically avoid it. Just use a : or a ? equal if you're getting started. That'll hopefully save some headaches. There's a phony target, which is kind of interesting. It's one of the built-in targets here. The way I'm using it is I'm saying that the phony target is all, and that all isn't a file on disk that I'm trying to get to. This is just like a placeholder. This is my default target. So I don't have to set the default goal variable. But then all only does reference the binary variable that we used earlier. And in order to get that, that's actually the third rule up here. And that uses the object files that we mentioned up here. So Make says in order to get to those object files, we need the second rule, which uses this wildcard character to match that for all object files. In order to compile those, I need to use my C compiler. I need to pass these flags to it. The dollar, we talked about the automatic variables here. $@ is the target name. Dollar less than is the first prerequisite. And $hat is all prerequisites. So the @ sign here is whatever is the name of the target here, not all that, but just the .o. So when it's going through, it'll say in order to get to hello make.o, I need to depend on hello make.c, and then any of the other dependencies I have, like this header file. I use the C compiler that we set up here called GCC. We then use the C flag, the O flag, we save that result into the hello make.o, which is the name of the target that we're currently working on. And then we use the hello make.c file as our first prerequisite as our source file, and then we use those C flags. And then when we want to make the hello func.o, some hello function, we do all that same thing again, but we've only specified that once. So we saved a little bit of typing around of what the different things are. And that way, if we have a different way that we want to compile the O files or something, we just have to change it one spot. We don't have to repeat ourselves, which is nice. And now that we've got all of those objects, Make says now we can actually build the hello make binary or the mat binary if we've overwritten it. And to do that, we don't use the C flag, we just use -o. We save it as whatever the name of that target is, which allows us to do the overriding name. Then we use all of the dependencies, which is all of those O files that we mentioned earlier, and then any of the additional C flags that we needed to specify. And we're done. We built our binary. It's that easy. There's a couple other rules here. The install target's also a phony target in that it doesn't make a file called install in the directory. What it does is it just copies things back and forth into whatever the prefix is, named whatever the name of the binary is. Because we gave the user the option to change the name of the binary, we need to continue using that variable and things. And then we have an uninstall target, which just removes the binary off the disk. And I missed marking that as a phony target here. And then in this uninstalled target, we can see that there's a couple of different rule prefixes that we can use. There's a single hyphen that you can put in front of your rule, which then ignores any failures of that command, just pretends that it passes. And then there's an @ sign which hides the output of that command. So we don't need to tell the user that we're echoing out to the screen, removing the binary. We just want to say that we're removing the binary. Maybe there was an old version of this program where it was called hello, and it didn't have that variable name or that binary name overriding feature that we do now. So let's just go remove that old version too, because maybe that's still there. We don't care if that succeeds or not with that command. Any questions about that? This? It's a much bigger example. Am I going too fast? Too slow?
Cover auto tools next?
Too clear? We're not touching on auto tools today. This is just about Make. There's enough in Make there. So I promised some tricks in the description. For those that already know Make, you're like, this is boring. Let's dive into some neater stuff that you can do. With a couple of commands, you can add a neat like help output. So when you type just Make, it then goes through and you've now self-documented that, so if you, for the help target, go dig through the Make file, find all of these lines that start with #help, and then print that out with like a nice little like tabbing out, so that way it says this is the help message. So that way, one of the other big conventions is you put a Make file in a project, somebody knows when they check it out or somehow acquire it, that, they can just type Make, and Make all should be able to build it, or if you type Make help, then maybe that'll list off something. You can set this as the first rule, you can set this as the default goal, so that way when you just type Make, it then tells you all the different things you can do in order to compile this project, or deploy this project, or maybe there's some other things that involve this project that you can do. So it's that allows Make to also be a good starting point of, well, it's got a Make file. I know how to use Make. What do I do with it? And gives newcomers to your project an easy way to know what the different things are that you can do inside that project. You can export variables. So we talked about using variables out of the environment to change how Make works. If you want Make to set environment variables to change how other programs work, then you just have to prefix them with the export command. So you just type export, like log level is a good one. It'll default to be debug, but maybe on your CI/CD system or on something else, you want to set that log level to be higher up. So in the environment of the CI system, you can say the log level only needs to be warn or error. Now go do all the running of build processing and automating and everything. So that way on the local developer system, it defaults to a more debug, verbose type logging, but then over on the automated system that nobody ever looks at because email's super hard, then it just only shows the errors. So there's only errors there and not all the multiple lines of, oh, I compiled this correctly. It's like, good job, you're supposed to. You're a CI system. But yeah, so to highlight again, the question mark equals is what allows the variable locally to Make to be overwritten with an environment variable. And then the export command before all of that is what allows that variable to be exported into the environment of the other processes that Make runs. So don't use a colon equal here. That won't do what you want it to do. Don't use a regular equal. That also won't do what you want it to do. Make gives you parallel builds out of the box, which is still pretty cool too. You can just do -J and have a number of different jobs execute at the same time. So if multiple targets are specified, or like the advanced example where we had multiple .o files being constructed, Make will just run both of those at the same time, wait for all of those to finish, and then run the final binary step. So you get multiprocessing out of the box, which is kind of cool. There's a GNU tool called nproc, which just lists off the number of processors on the machine. So if it's purely just a processor-bound thing, like you could just key in 4, or you can use nproc to say, oh, this is a 24-core who's what, so I want to use all those. You can just $nproc. That's just another Unix utility, not related to Make, just another tool, tiny little shell scripting right there. If you do that though, you may want to use the -O option, which then buffers the output from all of the jobs until Make finishes either successfully or with an error, and then spits out each of the jobs and their output individually. If you don't use that O option, it'll just throw it all to the screen as it gets it, which can be kind of garbled. You'll have, here's where it failed, but then 2 lines above that is where another job succeeded successfully, and then 2 lines above that is where you finally see what the error was that caused it to fail. If you wanted to force a target to be not parallelized, then you just put not parallel in front of it and say, just like the phony target, you just say it's not parallel, and now Make will wait for the other jobs to stop to do that job and then continue on again. So if you had something that was locking for some reason, like something that used the serial device in order to make the Arduino do the thing, it's like, well, you don't want that to try to use the serial device multiple times. You only have one Arduino on that port, so that would be something that you could do. Dynamic targets, I actually pulled this from my company's project. You can do the wildcards there, like we showed earlier, that just match the target there. But what we're doing actually is down here, just to show that we can do stuff. I'm highlighting on the wrong side. Down here you can, just to show off that Make is declarative and you can kind of put variables wherever. Like this isn't good form, but just showing off that it's possible. You can have a list of different components, a list of different operating systems and architecture combinations. And then your binaries is this using the for-each function to unroll that combination of different components and different operating systems and architectures to make a series of different binaries that you want to produce. To make it easy on the peoples, we put a target called binaries. That's easy to type and remember instead of all of those different combinations now, which just resolves to the bins variable. And then, for example, the uplink underscore Linux underscore AMD 64 target would then trigger on this target, or this rule definition. And then using the word and substir functions, you can then pop out each of those different parts again. you can get what the component is because that's the rule that you're in. But to get the operating system, it's now the second field using the underscores, the delimiter, and things. The architecture is the same way. You can then go set those two things and then go run another target called binary that then, once those variables are specified, it knows how to construct that binary. So to do this, you can then, adding a new architecture when your code supports it is as easy as just adding to that line. Simple one-line change, easy to peer review. People love little one-liners like that. There's another tool I very often use with Make called enter, which just watches a list of files that you pipe into standard input and then runs a command when any of those files change. So I add literally these two lines to my Makefile, and then in one window I type make watch, and then I split the little tmux screen and go over to the other side and I start editing files, and as those files change, Make is then run and it only builds the things that it needs to because it built that dependency graph each time. So super simple, love enter, it's amazing. You can install it with apt, I know, and you can probably get it with brew and other sources too. It's an older tool as well, so should be pretty prominent at this point. But yeah, man, my life changed when I found that tool. There's a talk about building static sites coming up later today, I believe. Hopefully one of the tools he talks about is called Hugo. So Hugo has a way that you can have it automatically do some of the serving for you, but when you want to actually build and deploy your site, then you could use a Makefile to automate that. You can just type make build and it'll build your site for you. You type make deploy, it copies it up to your web server, you're good to go. You can then wrap that around using enter with the watch command or the watch target that we did earlier if you wanted to, and just have automatic live things just going out to the website. So that'd be cool. You could use it in pen testing too. So say you have a King of the Hill contest or something and you have a new subnet you want to scan. You could have a little project that you check out and a Makefile here, so you just set the subnet variable to be whatever the 10.250, whatever you said it was, and then hit make and map, and it'll go scan that network, save it up to a file, make that directory if it doesn't exist already. It won't do, this isn't set up to do it in parallel. If you broke it out though, so that way each system was its own variable or something, then yeah, you could say go do it in parallel or something. That's all I've got for slides. Any questions? Anything that wasn't clear that I could recap?
You showed for each, and I forget, that was another one, built-in functions. Is there a Turing complete sublanguage in Make? Can you say make primes and it just prints out primes?
Using just make functions though?
Not executing any other program.
Right. I'm not sure if you could. I'm not that well versed with the function list. I know there's the different looping constructs and things. And then you could have different targets. You could do the dynamic targets things. You can do some sort of string comparison and whatnot. You might be able to pull that up. I'm not sure about the initial generation of the loop though.
Okay, challenge for you.
Just Google that one because it's old enough. Somebody's probably already done it.
Everybody cheats.
Everyone builds on the shoulders of others. Cool, that's all I got. Again, the slides are on the website there because there were some of them were pretty dense. So.
I have a question.
Yeah.
So, in your pen testing, for instance,
Mm-hmm.
are you using Make often other than, I've always thought of it as the first compiling. Are you doing it for things like that?
So the question was, am I using Make in my pen testing stuff? Not a whole lot, since I'm still new enough with the pen testing stuff. I don't really know what I'm trying to do. I've written a couple of just scripts that I use. I'm not using Make directly though for those. It's just give it an IP address and go do the things that I know how to do. I do use Make to compile some of the tools that I use for the pen testing stuff though, and then bake all those into a container image that I can then use repeatedly.
Another one to reiterate, this isn't about C. I use Make to, for example, build Docker images. I said make Docker and it goes compiles everything with Docker.
I mean, as long as you can express things in terms of files and dependencies, it's totally you.
Yep. Since you mentioned it, and I forgot to put it in my notes because it came up when I did the work presentation too. Also, bounce your presentations off your coworkers. It's loads of fun. Somebody asked about Docker containers as well. The question or the statement was that you can use Make to build Docker containers. Docker containers don't exist as a thing in that directory though, so Make could get a little weird with it. You can either just use phony and rely on the Docker layer caching thing to just handle changing what needs to be changed. Another thing I've seen is people will then build their image or do their thing that doesn't result in a file and then just touch like a empty placeholder file.
You can get the hash from Docker, store that locally.
Yeah, you could then get the hash and then write that out or something to the directory too. Yeah.
So you listed some things that you could use Make for. What are some things that you absolutely should not use Make for?
Toast. Prime numbers.
Make for the
Possibly prime numbers, yeah. So what should you not use Make for? Possibly prime numbers, toast.
To build an orchestration suite.
You could do a fair amount of orchestration with Make, I think. Yeah, when you start getting into the weird, like I needed to do a thing, but I can't represent that it's changed as a file on disk. So like that's where stuff starts to get weird, and there's probably a better tool for that. So like the Docker layers option or reference earlier, like doing stuff with hardware, like if you had that serial port in Arduino that you wanted to talk to make it do the thing, you don't really have a good way to say like when was the last time that firmware was updated on the Arduino itself. Like I built it at one point, but when was it updated over there? I don't know. So then like maybe you just use a phony target then say like I'm going to flash it anyway regardless of whatever it is. So yeah, then you started getting, when you the code smell is like when all of or the majority of your targets are just phony targets, then maybe Make isn't the tool you should be using for this. Cool. Thank you.